Hi, this is Margo. This is Sunday afternoon, November the 3rd, 2019, and I'm going to do a methane update showing CHEMS data and NOAA data, and we're going to look at sea ice and a little bit on Climate Reanalyzer, and we'll do an earthquake roundup from this last week. So I hope everyone is doing well, and that if you live in a country where you had to change your clocks, that you remember to do that. And we got an extra hour today, so how are you spending that extra hour? I'm feeling a little bit out of sorts with just things off. I was hungry earlier than usual because, you know, everything's an hour earlier now, or later, or whatever. But anyway, hope you're doing well wherever you are. I'm going to start by showing, this is off of NOAA. This is the Global Monitoring Division Earth System Research Laboratory. This is their monthly methane, and the latest data they have up is from June of this year. And in June, at the end of June of 2019, the global monthly mean, the measured at 1860.2 parts per billion. In June of last year, it measured 1852.0 parts per billion. So it had gone up 8.2 parts per billion globally for the last year. Now here's their graphs. This one, if you click on it, and you can click again and it'll enlarge. This is starting in 2015, and here it is at the end of June. Each dot is a month. It's the end of a month, each red dot. And then they did the average, the line, see how it's been going up. So from 2015, it started out at 1833 parts per billion, and then it typically goes down. So this was January, February, March, April. Then it started going down. May, June, July, August. Then it started going up, and so on. And so it typically goes down in the springtime and then starts going back up in the summertime around July, June or July, until around November or December, and then it starts going down again. That's been the typical curve of this, that we can see that when it comes down, it's higher than the lowest level from the year before, and when it goes up higher than the highest level from the year before. So it's been on a gradual increase here, and this year it started going back up sooner than expected, and then came down, and here it is in June at just under 1860. It had been up to 18. It's hard to see these. 1, 2, 3, 4, 5, 6, about 1866 parts per billion. That was earlier this year. Now they don't have the data up since June. And then on this chart, this started in the early 1980s looks like around 83, 84. And at that point it was about it was under 1650 parts per billion. So since 1984 to 2019, it's gone up more than 200 parts per billion. And it's on a steady rise. It's not going down. So I'll leave the link below in case anybody wants to look at that. I have this in my bookmarks. But I've been tracking it this year. Let's look at. Now I haven't reported since October the 20th, so there have been 2 weeks, but I'll just show you the spreadsheet and for the last couple of weeks. Now here's the data from NOAA from yesterday. This is, I measured the METOP-1 and METOP-2 satellites at 477 millibar. That's the reading on the little GIF that you click on. It says pressure 469 up at the top, but 477, 469. So here the range is from 1435 to 2407 parts per billion, and the mean is 1888. And this fuchsia colored, it starts at 2000 parts per billion and goes up to the highest reading. And this white areas is where there's no data. So we can see a lot of this fuchsia color up in the northern hemisphere here. And this is about halfway up in the atmosphere. Here it is from the afternoon reading, and we have missing data here and down here. The mean was 1888, the same. The range was 1474 to 2443, so that's higher. We're seeing some fuchsia color over the Antarctic here as well. Here's the METOP-2 satellite from the morning of Saturday. The mean is 1871. Now this satellite typically is lower than the other one. The range is 1444 to 2366. And in the afternoon reading, the mean was 1869 and the range was 1451 to 2382. So that's what's going on at NOAA. We're seeing fuchsia over the Antarctic down here too. Now here's the spreadsheet. And here's where I've plugged in the numbers, added them up, divided them by 4. Hang on. Okay, I was just checking something. Divided them by 4 and get the average for this 477 millibar reading. And it was 1879. Now last week, here are the numbers up here. There were 1893, 1890, 1875, and 1871. And so that averaged out to 1882.25. So we can see, now when I did my last report, we were at 1884.75. So we can see in the last 2 weeks it's been steadily going down at this level in the atmosphere. Last week, or from last Saturday, it had gone down over a week ago. Last Saturday on the 26th, it had gone down 2.5 parts per billion that week, and now this week it's gone down 3.25 parts per billion. So we can see the line is curving down in these last couple of readings. So the highest reading we've had so far since March of this year was 1885.75, which was right here. That's been the highest reading, and that was from October the 12th. So we may have hit the high for this year. We'll see. I'm going to keep tracking this, but it's still up since March the 1st. It's still up 21.75. See. So you got to do this on a long-term basis to get anything, to figure it out, to see the trend. So here it was in June, towards the end of June, where it had gone down, and then notice in my readings it's gone pretty much steadily up since then. So when NOAA puts their readings out, we'll see how much it goes up. So this is interesting to track this and then compare it with their chart as well. So 477 millibars is about 20,000 feet up in the atmosphere, or 6,096 meters. So there's that. Now, while we're on methane, let's hop on over to CAMS. Their latest data is from Thursday, the 31st. I have the Arctic view pulled up and surface level pulled up. Now, here's the chart down here. This dark brown is between 2160 and 10,000 parts per billion. So, let's get this movie going. I've already loaded it up, but it might be a little jerky since I've been sitting here. We can see the overall background color across Russia and Siberia is this yellow-orange color, which is about 2040 to 2060 parts per billion. When it gets into the orange, it's 2080, then the bright red is 2100, and then it keeps going up from there. Now in the forecast period, we can see that yellow moving out into this East Siberia Sea, and we're also seeing it moving out over here in the Kara Sea. We can see the Yama Peninsula is releasing high levels of methane. This area of Siberia continuously releases high levels as well. We can see degradations in the different shades of green, and the lighter the green, the higher the methane release. And this is coming up from the surface through the sea ice as it's trying to refreeze. Still seeing releases on Iceland. Sometimes we're seeing them here over here on Svalbard. Now the circle of darkness is increasing. The sun's going down up there, and a lot of Greenland is in the dark. Svalbard's in the dark now, and the darkness is reaching almost to all the coastline of Russia. I can show you that on NASA World View today. So if we go to another view, let's go to the North Pole view, and we can see the whole northern hemisphere here. We can see huge releases of methane down here in Asia, and this is ocean. A lot of this is ocean where it's coming out. Here's India. Now this is between India and I believe it's Malaysia. But this area, that's the ocean. And to get a better view of that, you can go to Southern Asia. Let's look at the Southern Asia view. There it is. It's so dark. You can barely see the coastline here. And then this huge release is here in the ocean. And it's just a big blob over here, over all these different little islands and lands and stuff. This is the Tibetan Plateau. That's why it's higher up, and that's why we're seeing less methane. Although we are seeing a high release right up here. Here's Mongolia, and then this is Russia up here. We can also take a peek at North America. North America. We can see it's really expanded over here in California. Here's Southern California, but this is up here. This is San Francisco, and coming all the way down the valley and all the way up where they've been having all those wildfires. So lots of methane there. Also over here on the east side, on the east coast, and then coming up along that North American craton basically. And we do have high releases in Florida. This is typical because it's so hot and humid, and there's a lot of toxic water down there with all the swamps and things. It's also very densely populated. Now if we look at the global, here it is, the global view for surface level. We are seeing release from the Antarctic around the different areas where the sea ice is coming away. So we can see most of the northern hemisphere is at least in the green in this 1960 or 1920 and higher. So if we change this to 500 millibar reading, that's what it looks like. Now, in order to get the correct color ledger for that millibar, you have to refresh. And here's the color ledger, and their numbers overlap, so it's hard to see. You'd think they could fix that. So that's 1920, 30, 40, 50. So this is 1950 to, and it looks like 2360. That's what it looks like to me. So we can see areas that are very dense, This is pretty close to that 477, like what I was showing you from the NOAA readings. See? But it's pretty dense over the Arctic region. And then total column, this is where all they take a reading through all the layers and then calculate the total column. And then let's refresh this so we can get the color chart. That's 2320 right here at the top, 1900. $60, $80, $90. So it looks like this darkest one is 1920 to 2320. And this looks awful. And we can see that it's worse. It's worse. Even though methane is going down, overall, you know, it's moving out, moving through all the different layers, and total column looks much worse. And we're seeing dark brown here over South Asia, then the red, and then red moving out across the Pacific. And we were also seeing red. I was seeing some red even up in the Arctic region. Now if you change some of these views, more red will come into view. Here's the Pacific view. Here's Kamchatka, Russia, and so we can see it's even red over here. Red going up, red coming across the Pacific, and then a red-orange moving across. And I saw areas last week of red even over the United States. That's the first time I'd seen that. If we look at the Arctic view, this is what it looks like. Here's Siberia. It's got some red coming up out of that area. There, we've got a few spots of red, and then the red-orange. Look, red-orange even over Alaska. Up here in Canada, they've got some red up here. This is the US-Canadian border, it looks like. And while we're here, we've got ozone. Click over to today on the ozone. This is measured in Dobson units. We're seeing a thinning over Greenland. This is about 240 to 260 Dobson units. Then once it gets into the chartreuse color, that's 260 to 280. So when you see the green, that's getting low. And then if we go to the global view, we've got a huge thinning over the western United States, over the Pacific, over the Atlantic, and all the way around the mid-latitudes. And here it is in the Antarctic. This is the lowest area that's left, and the little hole has migrated up to the Weddell Sea and by the western peninsula there. So let's leave methane. I'm going to leave this as a background. Yeah, we're going to leave methane and ozone for right now. Okay, what was I going to show you next? Got a slideshow. Okay, I downloaded these pictures from Climate Reanalyzer of the snow and sea ice. This is from today, November the 3rd. Now, I did my last show on this on October the 20th, so it's been a couple of weeks. So we can see that the extent it is at its lowest for ever for this time of year, but we can see how it's very thin. It's very thin, but it's trying to come back over here in the East Siberia Sea, the Chukchi Sea, Beaufort Sea. It's doing the best it can. We can see Baffin Bay is still pretty much ice-free. It's refreezing on the eastern side of Greenland. It's coming down around Svalbard, and it's about to touch Novaya Zemlya. So we can see where this was. As we go back, we can see this is our backwards slideshow. I think I missed one day on recording this. I get sidetracked with doing things. So here it is from 2 weeks ago on the 20th, and this is where the extent was. I missed the 28th. And here it is today. This is the Navy sea ice thickness from today. Now what you have to look for is the date up here. They put the year first, then the month, and then the date. And I had to go to a different place to get this picture, and I'm going to show you that in a minute. Sometimes they don't have, when you go to the Navy website and you click on the images, and sometimes it's not the current date. I'll show you that. Now the date here is the date that they took the reading, and it's projected out through their model. So they took this reading on October 31st and projected it out to today. So here is the extent for today. We can see that little hole there, and it's very thin, just very, very thin. It's just above 0 to about half a meter, or less than half a meter, maybe a quarter of a meter thick. That light lavender color. As it goes darker into the purple, the dark purple is about 1 meter thick, and then it goes into the blue. The blue is about 1.25. See this navy blue, and then the dark aqua is 1.5. And then the lighter aqua is moving on up into 2 meters and so forth. So it's not very thick, but that's what's happening there. Here's the 30-day animated gift from the Navy. Goes back 3 weeks and forecasts out a week. So the forecast goes to November the 10th. So you can see how it's filled in quite a bit in the last 3 weeks. There's the 7th, 8th, 9th, and here's the forecast where they expect it to be for the 10th. I also created this little movie for you from NASA Worldview. This is the sea ice concentration starting from the 18th of October, because that's where we ended with the last animation that I showed you, and it goes through November the 1st. So you can see each day it's come back a little bit more, but we can still see a lot of blue, and the blue means it's not as concentrated. The white is more concentrated. We can still see an area right down here below the North Pole that's still in the blue, so it's not very concentrated. Or it could be thin even. The thickest part is right down here, which is what we saw on the Navy website as well. Okay, we're going to leave that. And now we'll go on over. One thing I wanted to show you on this Navy website, you have to be careful. So here's the sea ice thickness. If you click on this little picture, normally it shows the current day. But if you look up here, it's showing November the 10th. So they've got the wrong date up here. So the way I got November the 3rd is I went into Snapshot Archives, and it's got, here's November, and oh, I think I got this one down here, but you can get, here it is, here's the latest one that was run on the 1st. That looks the same, pretty much the same. So that's for November the 3rd. Then, so all the archives for the last couple of years are here, 18th and 19th. And then they've got archives that go back through the 2014. And then for the animated GIF, you click there. But it was weird, for the sea ice concentration, they've got November the 10th up as well. So, I don't know why that happened. Sea surface salinity is for November the 3rd. So we can see the salt water mixing in with the fresh water more and more. And that's one thing that keeps the ice from refreezing and keeps it thin. Here's the sea surface temperature. That's November 3rd. It was red on November the 2nd. And so on. Alright, let's go on over to National Snow and Ice Data Center. This is sea ice concentration for yesterday. And we can see this correlates with what we saw from NASA Worldview. And the more blue, the less concentrated it is. Here's our chart for the daily sea ice extent. It's the area of ocean with at least 15% sea ice Now the dotted line was 2012. That was the lowest ever on record. The blue line is this year, and we've crossed the 2012 area, where, like around the 1st of October, where in 2012 it was at its lowest and then it started refreezing. Well, this year we're below that. So we're at the lowest ever extent for this time of year on record. We're still below it. If you want to look at the Antarctic, you click here. I have sea ice concentration pulled up. It's melting pretty fast down there, and the sea ice normally melts. Most of it melts around the continent every year, and then it refreezes. And this is salt water. And so here's the chart, and it's tied for the lowest ever with last year, right here, for this time of year. So there's that. Now let's hop over to NASA Worldview. I just wanted to show you when they want to block something out, all they do is put a big black thing. I don't know what they're trying to cover up there. It's in the middle of the Pacific Ocean. That was from yesterday. If we refresh, let's see if it's still there. Yep. So that's what NASA does. They just block it out. And this black line, that's where it's in the dark. Let's go to today. Well, that black area is gone. And look, it's covering up this swirl. A system, large system, it looks like. Now let's go on up to the Arctic. And this black area is all in the dark. We can see that Novaya Zemlya is covered up, except for this little tippy point. Svalbard is in the dark. About half of Greenland is in the dark. Half of Baffin Bay. These Canadian islands are all in the dark. The Beaufort Sea is pretty much in the dark. This is data that hasn't come in yet today. Parts of Russia, Siberia are already in the dark. Just a little bit of coastline up here in the Chukchi Sea is in the light. And over here. Let's look at yesterday. Here it is yesterday. So it's all dark where the sea ice is, so we don't have a picture. We can't tell anything about the sea ice. Hardly. We can see where it's come back here. There's a little bit of sea ice that we can see around the coastline. And this is Bennett Island that I did the show on yesterday. It's in the dark. If you want to take a peek at the Antarctic, see what's going on down here. Here's today. Still got a little bit of data left to come in down here. I wanted to show this A68 iceberg that broke off. This is the edge of it right here. It's about to go out to sea. This broke off, this right in here, off of the Larsen Sea Ice shelf a couple of years ago, and it's been gradually moving around, making its way, trying to go out to sea. It's been pretty cloudy, so it's hard to see it, but I know the shape of it and can make it out through the clouds there. There it is. This is the Western Peninsula. Here it is. This is under cloud, a little bit of cloud cover. Totally can't see it there. Here's the edge of it there through the clouds. Look at those ripples. Lots of ripples. Lots and lots of ripples there. Here's a good view of this end of it, and see there's not much ice around it. Look, and this ice is quite thin, so if it gets any momentum, it's going to be going out to sea. And this is a huge iceberg. I don't know what they're going to do with that. Here's a good picture from the 25th. See on this right hand side how free it was from any ice. There was a little bit of ice there. That's gone. It's pretty much intact. It's there have been some pieces breaking off over here where we see this indentation, but it's pretty much intact from where it broke off. Here's another good picture of it from the 23rd. There's some clouds over it. The 22nd, 21st, and here's from the 20th when we did our last show and showed you this. So you can see it rotating. And there it is today. We can just see this little, through the clouds, little edge of it. So I'll keep y'all posted on that. Down here, getting lost. Right down here is the Pine Island Glacier. You can see no ice. All of the ice that was next to this ice sheet has already pulled away. And we'll see if this calves off some more this year. A huge piece broke off, calved off last year and the year before that. It used to come out down to here. There are active volcanoes underneath there. Here's the Thwaites Glacier area. Here's the Ross ice sheet. McMurdo Bay is down here. Wait, I'll show you. McMurdo. They've got a base. Base, not bay. It's over here somewhere. This is Ross Island, where Mount Erebus is. It's an active volcano. Over here is the Amory ice shelf. I remember there was this piece broke off. They have a line where it used to come out. That piece had broken off. It's called D28. We can't really see it here. It's It's over here somewhere. Can't really see it through the clouds. And it looks like it's kind of like merged in with the sea ice or something. I can't see it right there. The last good picture I had of that we can see a little bit of it right there. It's from the 25th. Here it is from the 21st. That was the last good picture we had of it. You know, it's funny how they have these breaking stories and then nobody follows up on it. So here is the Antarctic from today, with just this little part waiting for that data to come in. So now we'll briefly look at Climate Reanalyzer. Here's the 2-meter temperature anomaly map from today. We can see that this area over the Arctic is in the red zone, up into 20 degrees Celsius warmer than normal. We've got parts of Siberia moving into the red and from the brown. And here over the Baffin Bay, remember this part's in the dark. This is in the dark, so even with it being in the dark, it's warmer than normal. And so the world is 0.6 degrees Celsius warmer than normal. The northern hemisphere is 1.2 degrees warmer than normal. The Arctic is 2 degrees warmer than normal, and the Antarctic is 2.1 degrees warmer than normal. We can see down here over the Antarctic, it's a lot of that's in the browns and moving into the red zone. New Zealand is in the brown. Here's our temperatures, maximum temperatures today. So remember, in the northern hemisphere it's moving, it's November 3rd, so we're switching seasons from fall to winter. And then the southern hemisphere is moving from spring into summer, so we see a lot of reds, a lot of hot temperatures down here already. Here's the precipitation map. The blue is snow. So it's snowing over the Arctic, a lot of the Arctic. With the green is rain. So we have a wide band of rain going around the middle part of the mid-latitudes there. I've got a big system there. Something going on over here. I'm not a good weather girl as far as rain and stuff like that. Here's your jet stream. Snaking around and splitting into two over there. We got a couple of jet streams in the southern hemisphere, looks like. Sea ice and snow cover, we already saw that. Sea surface temperature anomaly. This is from yesterday. We can see this part over here, the Beaufort Sea is pretty much brown. That's where it's not refreezing very well, not coming back very well yet. And over here in the Pacific, brown and into the reds. And over here, Baffin Bay and all around the southern end of Greenland, it's in the browns. So in the world, the sea surface temperature is 0.2 degrees higher than normal. Northern hemisphere is 0.5 higher than normal. The northern Atlantic is 0.4 higher than normal. The North Pacific is 0.6 higher than normal. The equatorial Pacific is 0.3 higher than normal. So I'm going to wrap this up for today. Oh, no, we were going to do an earthquake roundup, weren't we? Well, this is USGS, all magnitudes for the last 24 hours. 284 earthquakes worldwide. And I'm still monitoring this area down in Southern California, the Searles Valley Ridgecrest area. They've got 91 earthquakes here right now. It's been coming and going. The numbers are increasing from what they were. The lowest they got this last week was on the 30th. They got down to 32. So it's coming back up. So lots of earthquakes around this ring of fire. Over here in California, we just had a 4. This is at the geysers, had a 4.2 over here today at 12:34 this afternoon. So, and up here near Redding, California, there was a 3.1. Down here in the Dayton area, we had a 3.2 a couple of days ago near Reno. Let's see what else. Let's turn on last 7 days, all magnitudes. We've had activity over here on the Juan de Fuca plate. You can see that 5.2, that was the big one. Here's the Cascadia subduction zone. Lots of activity down in that area. And this North American craton, we had activity all the way up along there. So here's the Reno area. That's where I live. We've had quite a few. There was a cluster that happened over here in the Fernley area, clustering over there. Here's this Dayton earthquake, this 3.2, and that cluster there. So it's been pretty active. Let's see, when you see them like this for 7 days, you know, it fills in a lot of the gaps. You can see that it's all the way up and down. And also in this event area, it's spreading out. And here's the LA area. There was also, look at this cluster, Los Baños, 3.3. I thought I remembered a larger one there, 3.3 there on the 27th. So we can see that the earthquakes are getting bigger and they're more clustered here, all the way up and down this west coast. Oh, there's been a lot of activity in Hawaii this week. There have been 111 in Hawaii. Worldwide, there have been 2,060 earthquakes in the last 7 days. It's 111 in Hawaii this last week. And the red ones they just happened, they just came in. The orange ones are in the last 24 hours, and the yellow ones are older than that. So we're seeing a lot of activity up here at Kilauea, and on the Kilauea flank, also down here at Pahala. And this is Mauna Loa here. So there's been a lot of activity here. And then of course down in the Philippines, there was that 6.5? 6.5, that was the big one. A lot of activity down here on land in the Philippines. It's really, they've taken a beating this week. There's a 6.5, 6.6, 5.3, 5.0, and so on and so forth. So they've taken a beating this week. Here's a 5.1 up here off the coast of Kamchatka. Then Japan has had some activity off the coast of Japan. There's Taiwan. I mean, usual places. We also had this 5.0 near Dubai. Right here in the waterway. In Iran, near Dubai. So things are happening. The earth is moving. It's things are shaking up. Oh, right. I meant to show also we had another Arctic earthquake up here off the coast of Svalbard, between Svalbard and Greenland, was a 4.9. That one came in on October the 29th. Right on the red line, where the tectonic plates meet there. I'm always interested in those. And we had a big one, 6.1, down at the southern tip of the Atlantic. Africa also, this is areas we normally don't see them. A 5.3 in the Congo and a 4.3 in South Africa. .1 Southwest Indian Ridge. So we can see all around these lines there's shaking movement going on. So I hope everyone is doing as well as possible, and prepare for whatever you feel like you need to prepare for, but especially prepare spiritually, because I do believe we are in the end times, and we need to prepare spiritually more than anything, because no one knows the day or the hour when everything is gonna be the end for you, me, for all of us, or for some of us, or for all of us. So I recommend, if you haven't done so already, get right with God and Jesus. That's my spiritual preparation. So until next time, this is Margo. I love you guys, and I'll be praying for everybody. God bless you, and I'll talk to you soon. Go in peace, and goodbye.